Assalamualaikum warahmatullahi wabarakatuh, and a very good day to my lecturer, Professor MADYA Dr. NAZRI bin DAGANG. My name is AQILA binti SHOKI, and I am from Team 4. In this video, I am going to talk about one of the semiconductor device, which is photodiode. Photodiode are semiconductor-like sensor that generate a current or voltage when the PN junction in the semiconductor is illuminated by light. It is a type of photodetector capable of converting light energy into electrical energy in either current or voltage, depending upon the mode of operation. Solar cell is example of it. When a photon of sufficient energy strikes the diode, it excites an electron, thereby creating a free electron at a positively charged electron hole. This mechanism is also known as the inner photoelectric effect. This device can be used in three modes: photovoltaic as a solar cell, reverse bias as a photodetector, and forward bias as an LED. They are also called a photodetector, a light detector, and photosensor. As you can see from the picture given, this is the symbol of photodiode. The symbol of photodiode is similar to the normal PN junction diode, except there is contained arrow striking the diode. The arrow striking the diode represent light or photons. A photodiode has two terminals, which is a cathode and anode. For the next part, we will continue on how photodiode working. A photodiode is subjected to photons in the form of light, which affect the generation of electron-hole pairs. If the energy of the falling photon is greater than the energy gap of the semiconductor material, electron-hole pairs are created near the depletion region of the diode. The electron-hole pairs created are separated from each other before recombining due to the electric field of the junction. The direction of the electric field in the diode forces the electron to move towards the N side, and consequently the hole moves towards the P side. As a result of the increase in the number of electrons on the N side and holes on the P side, a rise in electromotive force are observed. Now, when an external load is connected to the system, a current flow is observed through it. The more the electromotive force created, the greater is the current flow. The magnitude of the electromotive force created depends directly upon the intensity of the incident light. This effect of proportional change in photocurrent with the change in light intensity can be easily observed by applying reverse bias. Since photodiode generate current flow directly depending upon the light intensity received, they can be used as photodetector to detect optical signal. Built-in lens and optical filter may be used to enhance the power and productivity of the photodiode. That's all from me. Next, I will pass it to Adam to continue our presentation.
Next is the advantages and disadvantages of photodiode. The advantage is the photodiode has better frequency response, linearity and spectral response than LDR. A photodiode is suitable in instruments that test the laser's pulse shape. It can operate at high frequencies in the order of 1 MHz. It can be used as a variable resistance device. And the disadvantage is it has rapid increase in dark current with temperature. It has small active area. There is necessity of amplification at low irradiance, and it needs offset voltage. Next up is the introduction of LED. In the simplest term, a light-emitting diode is a semiconductor device that emits light when an electric current is passed through it. Light is produced when the particles that carry the current, known as electrons and holes, combine together within the semiconductor material. Since light is generated within the solid semiconductor material, LEDs are described as solid-state devices. The term solid-state lighting, which also encompasses organic LEDs, distinguishes this lighting technology from other sources that use heated filament or gas discharge. The LED contains two terminals known as anode and cathode. The former contains a positive charge on it, and it comes with a longer lead as compared to other, and later contains negative charge on it. LED will be working under one condition. The anode terminal should be put at a higher potential than cathode terminal as current flows from anode to cathode, or positive to negative. LED won't conduct if the respective terminals are connected in the reverse order. Pictures in the slide is the LED symbol and an example of LED symbol in a circuit. The LED symbol is the standard symbol for diode with addition of two small arrows denoting emission of light. Hence the name light emitting diode. The A indicates anode or plus connection, and the C the cathode or minus the connection.
Firstly is how LED works. An LED bulb produces light by passing electric current through a semiconducting material, the diode, which then emits photon, which is light, through the principle of electroluminescence. It essentially means that a material, in this case the diode, casts light when power is applied to it. Electron jump from one side to another side across a junction, which is the PN junction. When power is applied to the PN junction, the side lacking in electron wants to be filled up with the charged electron from the other side. And when power is applied, the electron get eager to move, which is get energy. During this process, the light is created. In contrast, an incandescent light bulb works by passing electricity through a small wire or filament. The electrical resistance of the filament causes it to get so hot that it glows, producing light. The fact that LED do not rely on heat to produce light, meaning it is cooler and much more energy efficient than other light bulbs. Next is the advantages and disadvantages of LED. The advantages are energy efficient, safety, long-lasting, dimmable, slow failure, and more efficient. The disadvantages are high upfront cost, transformer compatibility, potential color shift over lamp life, performance standardization has not yet been streamlined, and overheating can cause reduced lamp life. Next is introduction of laser diode. A laser diode LD is a semiconductor device similar to LED, in which a diode pumped directly with electrical current can create lasing condition at the diode junction. Driven by voltage, the dot PN transition allow for recombination of a electron with a hole. Due to the drop of electron from higher level energy to lower one, radiation in the form of an emitted photon is generated. This is spontaneous emission. Stimulated emission can be produced when the process is continued and further generates light with the same phase, coherence, and wavelength. The choice of the semiconductor material determines by the wavelength of the emitted beam, which in today's laser diode range from infrared to the UV spectrum. Laser diodes are the most common type of laser produced, with a wide range of uses include fiber optic communication, barcode reader, laser pointer, CD, DVD, Blu-ray, reading, recording, laser printing, laser scanning, and light beam illumination. With the use of phosphor like that found on white LEDs, laser diode can be used for general illumination.
Thanks to AYOB for his presentation. Now I will continue to talk about the construction of laser diode. Basically, a simple laser diode has two metal plates sandwiched to the P-type and N-type layers by input terminals, and it also called as homojunction laser diode. The insertion region between the P-type and N-type material is used to increase the volume of active region, so that more number of holes and electrons can accumulate at the junction. This allows electrons to recombine with holes at any instant of time, resulting in better output power. The laser light is emitted from the elliptical region, and this beam from the laser diode can be further focused using an optical lens. This entire pin diode arrangement is enclosed normally in a metal casing. How does a laser diode works? Basically, the working of a laser diode takes place in three main steps, which is energy absorption, spontaneous emission, and stimulated emission. A laser diode consists of a p-n junction where holes and electrons exist, which means a hole is the absence of an electron. When a certain voltage is applied at the p-n junction, the electrons absorb energy and they transition to a higher energy level. Holes are formed at the original position of the excited electron. Then the electron stay in this excited state without recombining with holes for a very small duration of time, termed as recombination time or upper state lifetime. The recombination time is about a nanosecond for most laser diodes. This condition we call it as energy absorption. For spontaneous emission, after the upper state lifetime of excited electron, they combine with holes. As the electrons fall from high energy level to a low energy level, the difference in energy is converted into protons or electromagnetic radiation. This process is used to produce light in LEDs. The energy of the emitted proton is given by the difference between the two energy levels. Lastly is stimulated emission. We need more coherent photons from the laser diode than the ones emitted through the process of spontaneous emission. A partially reflective mirror is used on either side of the diode so that the photons released from spontaneous emission are trapped in the p-n junction until their concentration reaches a threshold value. These trapped photons stimulate the excited electrons to recombine with holes even before their recombination time. This results in the release of more photons that are in exact phase with the initial photons, so the output get amplified. Once the photon concentration goes above a threshold, they escape from the partially reflecting mirrors, resulting in bright monochromatic coherent light.
That's all from us. Thank you.